All right, so we have a 7.3 Newton force is applied horizontally to a 1.7 kilogram object that slides on a smooth horizontal surface. So this is our force, 7.3 newtons. This is the 1.7 kilogram block, and this is the, yes, 0.81 kilogram mass. Okay. First, what is the acceleration of the blocks? Now, they are connected together by a string that's not stretchy. So, they're each going to go the same distance in the same amount of time. So, they're going to have the same acceleration. Now, I have two bodies, and if we want to find acceleration, what causes an acceleration? A push, which is a what? Force. Unbalanced forces caused acceleration. Yesterday we had an unbalanced force and the car went down the incline. Today we had an unbalanced force and the car went down the incline. Unbalanced forces cause acceleration. So, in order to find acceleration, we've got to look at the forces acting on the system. How many bodies do we have? 2. How many free bodies do I have to draw? 2. So we got to draw our FBDs. So you're going to have a 0.81 kilogram free body diagram. I'm going to call this one M1 for the sake of simplification of writing stuff. So here's M1. And what forces would be acting on it? There is, well, M1 is going to be this guy right here. So what's interacting with that, the guy on the left? There is a gravitational force, absolutely. The Earth is pulling on it just like that, a gravitational force. I'm going to call it FG1 because I love subscripts, and it's the first mass. And then what else is acting on this mass right here? There is a normal force. I hear normal force out there. We have a normal force. And I have two objects, so I'm going to have two different normal forces, so I'm going to be really picky and call it F normal 1 because it's on my mass number 1. Okay? What else is interacting with our M1 of science? It's a smooth surface. So no friction. I heard it. Tension. There is a tension force, FT, between or on that block. So you should be able to name everything that's interacting with the block. The rope is interacting with the block. The earth is interacting with the block. And the table is interacting with the block, pushing up on it. Okay? Alright, so then let's draw the free body diagram for the other guy. I'm going to call him M2. So what forces are acting on M2? The gravitational force, I'm going to call it FG2 because it's my second mass. Anything else acting on him? A normal force. So force normal, and I'm going to call it 2 to be really picky. What else? A force applied to the right. And I'm going to go ahead and label him. I'm going to label him force applied, but it is 7.3. So just to remind you, that is where our 7.3 Newton force comes in. Anything else acting on this block? Tension, which way? To the left. You always put your pencil on the object. So take your pencil and put it on the object and follow the cord, and that'll give you the direction of the tension. If you're ever trying to find the direction of the tension. So now we have to sum the forces. On M1, I have the sum of the forces in the x direction. Oh, what do we have? The tension force. That's it. Is it balanced? No way. There's not even another force acting on it. So it's definitely going to equal, and I'm going to call it M1A. I love symbols. The forces in the y direction on that guy, we'd have F normal 1 minus FG1, but it's balanced in the vertical direction. It's not hopping up and down. All right, on the M2, we have the applied force to the right. We have the tension force to the left, so it's negative. Now, the system is accelerating because I'm looking for the acceleration, so it's not balanced, it's not an equilibrium, so it equals MA. So now we've summed the forces, we can solve.